I welcome everybody to the short tricks video. So here the main motive of this video is to reduce the difficulty of the problem, because most of the students feel that physics is one of the difficult subject to deal with. So here in this video I will be teaching you few important and very easy tricks which you could remember, which will also help you to solve difficult problems in fraction of seconds. So today what I am going to show you is one of the very important and a tricky question, where most of the students find it very difficult to deal with the rolling bodies. Here what I am going to do is, I am going to do a very small question that is related to rotation motion. In the rotation motion, rolling concept is one of the very important concept to deal. In that, we will see a body that is rolling down from an inclined plane, and they will ask you to find the acceleration of that body which is rolling down from an inclined plane. There, in many textbooks, you will find some complicated derivations which will lead to a formula. Only using that formula you will get to an answer. So here what I will give you is a direct formula in which if you just plug in the data that is given to you in the question, you will arrive at the answer straight away. So let me show you how it works. So this is a typical inclined plane, and assume that any body is going to roll down from an inclined plane. So our motive is to find the acceleration of the center of mass of the body that is rolling down from an inclined plane, which is inclined at an angle of theta. So the formula that I will be using here is ACM is equal to unbalanced load by total inertia. So this is the one that you have to remember, unbalanced load by total inertia. Okay, by the way, what is the unbalanced load? Whenever you place a body on an inclined plane, in the Newton's laws of motion that you know, immediately we write that the force which is parallel to the inclined plane is mg sin theta. So this is called the unbalanced load, and this unbalanced load should be written on the numerator. So ACM is equal to mg sin theta divided by, what is the total inertia? It is m plus I by capital R squared. I by capital R squared. So this is the exact formula that is going to help you solve this question in a single step. Unbalanced load divided by total inertia. Now all you have to just do is take the inertia of the body which is rolling down from the inclined plane. Let it be a sphere, let it be a disc, or let it be a ring, whatever it is. Just take the inertia of that about its center of gravity and write that inertia over here, and you are done. Okay, you don't have to do any complicated calculations for here. All that you have to do is write the inertia of the body that is rolling down from an inclined plane. Okay, so if you just do it, you will get the answer straight away. Likewise, if I ask you to find the acceleration of the center of mass for a body that is rolling on a rough horizontal surface. Let's say this is an horizontal surface and a body is rolling on an horizontal surface like this. You are supposed to find the acceleration of this rolling body, and we know that the friction acts on that rolling body will act backward. This acceleration is given as the force that is acting on it is capital F. That force is the one which is responsible for making this body to roll on the horizontal surface. So capital F divided by m plus I by r squared it is. I by r squared it is. See, both the formulas are actually similar, but there is only a very small change between these two. Here it is the unbalanced load, here it is the external force that is acting on it to roll. Okay. Likewise, if it is a sphere, you have to write the inertia of the sphere. If it is a ring, you have to write the inertia of the ring, and everything is settled. So this is how the whole thing works. Now I am going to show you a question. Okay, there I will be applying the same exact trick and I will show you how to solve it. So this is the question. A sphere rolls down on an inclined plane of inclination theta. What is the acceleration of the sphere when it reaches the bottom? So in here they have just given you it is a sphere. You might wonder whether it is a spherical shell or a solid sphere. Whenever it is given as sphere, you have to consider it to be a solid sphere. So whatever we are dealing here is just a solid sphere. So as they have said, we are supposed to find the acceleration of the body when it reaches the bottom. So the acceleration A is nothing but the unbalanced load, which is mg sin theta divided by m plus I by r squared it is. M plus I by r squared it is. So now I is nothing but the moment of inertia of the solid sphere. The moment of inertia of the solid sphere is 2 by 5 mr squared. 2 by 5 mr squared. If I just substitute that in here, you will directly get into the answer. Let me show you. Mg sin theta divided by m plus 2 by 5 mr squared divided by r squared. R squared and r squared gets cancelled away. Likewise, I can also pull these m's out and I can cancel it. What you will be left with is just g sin theta divided by 1 plus 2 by 5 it is. So if I take the LCM and if I take it to the numerator, it becomes 5 by 7 g sin theta. 5 by 7 g sin theta. So this is the final answer. You see, I don't have to do anything. The only thing that I have to remember to solve this problem is the moment of inertia of a solid sphere. Once I can remember that, all I have to do is take the entire equation and I have to plug it in the place of I, and rest of the things is a simple algebraic mathematics. So this will directly bring you to the required answer. For this particular question, the answer is option A. See, this is how easily it is done. You don't have to do anything rather than remembering this inertia in here. So now I just want you to try the trick that I have taught you now. This is the question that I would like you to try it in your home, which looks absolutely similar, but there are few things that you have to change. The only thing that you have to add in this is the angle of the inclined plane is given to you, which you are supposed to substitute at the very end. See, a thin uniform circular ring. Instead of sphere, you have a ring in here which is rolling down from an inclined plane where the angle of inclination is 30 degree. Okay, here you are supposed to find the linear acceleration again. Same trick, same formula. At the very end, try to substitute the angle that is given to you. You are done. So, I want everybody to give it a try so that you yourself get familiar to the formula and you can almost solve all the problems that they are asking you to find the acceleration. Whether it is going to be an inclined plane or it is going to be an horizontal plane, it doesn't matter. As long as it is going to be a rolling object, you will be able to find the acceleration for any body. So, With this note, I'll end this session. We will again meet with another trick in the next session. Thank you.